Hello again, everyone. Welcome back to our course in college algebra. Dr. Tom McNamara here. In this video, I wanted to discuss solving quadratic equations. So we've just had a few lessons over dealing with quadratic functions. And whenever you're dealing with quadratic functions, it automatically leads to dealing with quadratic equations. For example, if you want to find where the graph has x-intercepts, where the graph crosses the x-axis, you would take the function's formula and set that function equal to 0. Because if a point is on the x-axis, the y-coordinate is 0, so the output is 0. If you want to find out where the output is 0, you need to solve an equation. Okay? So, we'll review working with quadratic equations. There are two main techniques we're going to cover in this course, and the first one is factoring. So let's just get right into it doing an example here. Solve each equation by factoring. Now, one thing to make a note of is that when we solve an equation by factoring, we make use of something called the zero factor property. Okay, we make use of something called the zero factor property. And I'll just write it down here. If the product of two numbers is 0, then one of the two numbers involved had to be 0 to make that happen. And that's not true of any other number. 0 is the only number that has that property. If you're telling me you took two numbers and multiplied them together and got 36, well, there's tons of combinations that'll let you do that. If you took two numbers, multiplied them, and got 36, there's no reason that one of them had to be 36. You could have been using 12 and 3. You could have been using 9 and 4. You could have been using 6 and 6. You could have been using 5 and 36 over 5 to get that product of 36. But if you tell me you took two things, multiplied them together, and got 0, then I know one of them had to be 0. So we're going to make use of this zero factor property when we are solving quadratic equations by factoring. So our first step is always going to be make sure we have a 0 on one side of our equation. Notice it started with a -8, and I added 8 to both sides, getting an 18 over here. Okay, so once you have a 0 on one side of your equation, you look to factor the expression on the other side. So here we are working backwards from a multiplication problem. So we know that first times first would give us x squared. So I'm going to use an x and an x there to make that happen. Now, the thing you need to focus on when you have a trinomial like this with 3 terms, focus on the constant. I know whatever I put here and here, whatever I do, has to multiply together to give me 18. So I'm thinking of a couple possibilities right now. It could be 1 and 18. That's always an option. One of the factors could have a 1 right here, okay? Because 1 divides into everything. Okay, so 1 and 18 is a possibility. 2 and 9 is another possibility. And so are 3 and 6. This 18 is positive, so both of the quantities here will have the same sign. In the middle I have a negative, so that means both of the quantities here will be negative, and it doesn't take too long to figure out that this does the job. Okay, you can always check your factoring by multiplying, right? First times first gives me the x squared, minus 3x, minus 6x combined to give me a minus 9x. Finally, last times last is -6 times -3, giving us positive 18. Okay, so those are the two factors. Now, we can often just do this part in our head. I'll write it out. just to be clear, using the zero factor property, the product of these two quantities is zero. That means one of the factors has to be zero. So it could be the case that x minus 6 is zero, in which case x equals 6. Or it could be the case that x minus 3 is equal to 0, in which case x equals 3. So these are the factors, and these are the two solutions. Okay, so key things. Make sure you have a 0 on one side. Factor. Once you do have the factors, you take those factors, set them equal to 0 individually, and solve those resulting linear equations. Sometimes people get thrown off with a problem like this. They're usually pretty good at factoring the trinomials, but this is a bit of a curveball, a bit of an off-speed pitch here. We'll follow the same process. Get a 0 on one side, and I'm just going to take out the greatest common factor, which is t. Both of the terms are divisible by t. Pull out a factor of t. Okay, so I have factored the left-hand side. So if this is true, that must mean t equals 0 or t equals 2. I took that last factor, set it equal to 0, and solved it. Very easy one to do in your head there. Okay, so here's the last one I want to work with you on. Okay, so following our standard operating procedure, if we're going to solve this by factoring, we have to have a 0 on one side before we get started. So I'm going to take these two terms and subtract them over. So 2z squared minus 13z minus 15 equals 0. Now, what I'm doing at this stage is I'm thinking about my factors here. My leading terms are going to be 2z and z. All right? Notice I've got to have one of these with a 2 because that's the only way for me to get 2z squared in the expanded version. Okay, now what I'm thinking over here is, all right, I'm looking for what to put here and here. Those numbers have to multiply together to give me negative 15. That means they have to have different signs. One of them's positive, one of them's negative. Okay, that's the only way to get a negative product is to have two different signs. Now, it's not just a matter of having these two numbers together add to the 13. Over here, that's what we were thinking. We were looking at factors of 18 that added to negative 9. But here, the 2 is going to influence things. Okay, so there's no way for me to get factors of 15, two numbers that multiply together to give me 15, but when I add them together I get 13. Those don't exist. But fortunately, that's not really what I need. So I'm thinking about these numbers that multiply together to give me 15. Not a lot of options. 1 and 15, 3 and 5. That's it. So, let me do some thinking here. They have to have opposite signs. So, I'm tempted to do like, okay, well 2 times 5 would give me 10, and then 3, so that'd be 10z, and then a 3z, but I don't think I can make that work with the signs that I have. So I'm thinking I actually need this combination, minus 15 and plus 1. Okay, 2z minus 15, z plus 1. And as always, I can check my factoring by multiplying. First times first, 2z squared, got it. Outside times outside is a plus 2z. Minus 15z gives me the minus 13z. And last times last gives me the minus 15. So I've got the factoring correct. Now, this is where a lot of people get tripped up, so don't make this mistake. You've got the factors, great. We set each factor equal to 0 individually and solve that little equation. So, if z plus 1 is equal to 0, that means z equals negative 1. That's one of the solutions. Now, a lot of people just look at that last number and they take the opposite of that. That's not what you need to do. Take this expression 2z minus 15 equals 0, and solve for z. Z equals 15 halves, right? You add the 15 over, then divide by 2. Your answer is a fractional value for z. So keep that in mind when you have something like this. Okay, so the key steps: get a 0 on one side, factor, set each of the factors equal to 0 individually, and solve the resulting linear equation. Okay?